Okay, now we look at the last example in this chapter, example 14. So an air-filled parallel plate capacitor has a rectangular plate with dimension of 6 cm times 8 cm. So it is connected to a 12-volt battery. So while the battery remains connected, okay, this is a very important information. While the battery is remain connected, a sheet of 1.5 mm thick paper is inserted and completely fills the space between the plates. And the dielectric constant for the paper is 3.7. Okay, so now we have a capacitor connected to a battery. So this is the capacitor. And then this is the battery. So we have a battery and capacitor. So while this capacitor is connected to a battery is 12 volt, and then the area is 6 by 8 centimeter square. Okay, so while it is still connected to a battery, okay, a piece of paper is inserted in between this capacitor. So diletakkan kertas dekat sini semasa masih lagi connected dengan battery. So this one adalah case number 2. So apabila kena ingat apabila dielectric ni diletakkan semasa capacitor masih lagi connected to a battery, okay, V adalah constant. Okay, tu yang penting kamu kena ingat. V adalah constant. So let's write down the information yang kita ada. So voltage adalah 12 volt. So maksudnya dekat sini V will be equal to V0. And then the area dia bagi, which is 6 times 8 cm square. And then the dielectric constant for the paper 3.7. Okay, soalan first, explain briefly what is happened to the charge. So what happened to the charge on the plates of the capacitor while the dielectric was being inserted. So we want to know what happened to the charge. Okay, macam mana kita explain? We just can explain using this formula. Q is equal to CV. Okay, since V here adalah constant, right? And then we know that, okay, setiap kali dielectric, okay, when dielectric is inserted, okay, capacitance will increase. Ni adalah untuk kedua-dua case. Bila kita letak dielectric kan, capacitance ni dia akan increase. So according to this formula, so when, okay, since V constant, so when capacitance increase, so ni kamu tulis dalam bentuk perkataan lah. When capacitance increase, okay, charge pun akan increase. So thus charge will also increase. So that one, so explain macam tu je untuk question A. Okay, now question B. Okay, determine the change in the charge, okay, of the capacitor because of the dielectric of the insertion. Okay, we want to find the change of the charge, which is delta Q. So kalau change mesti delta Q, meaning that, okay, delta Q will be equal to Q minus Q0. Final minus initial. Since final ni dia akan lebih tinggi daripada initial kan. Alright, so how do we find this? Kita kena cari satu-satu lah dulu. Q and Q0 dulu. So let's find Q0 first. So Q0 is equal to C0 V0. Okay, but kita tidak boleh cari using this formula sebab we don't have the value for C. C0 kita tiada. So we can find C0 first, which is C0 is equal to E, okay, epsilon times with area divided by the distance. Okay, epsilon dekat sini adalah, okay, initial, kalau initial adalah semasa in vacuum, right? This one is in vacuum. So maksudnya dekat sini ni adalah epsilon naught. So 8.85 eksponen negatif 12 darab dengan area. So area dekat sini, mana sudah area tadi tu? This one kan? Okay, kita ubah kepada meter square. So 4 darab 8, okay, akan dapat 4.8 eksponen negatif 3 meter square. So 4.8 eksponen negatif 3 divided by the distance between, which is, okay, this value is the value for the D. 1.55. Okay, 1.5 je kan? Is it 1.55? Okay, 1.5 eksponen negatif 3. So dapatlah C0, which is equal to 2.8 eksponen, 2.83 eksponen negatif 11 farad. So dapat C0, bolehlah cari Q0. Q0 will be equal to C0 V0, which is C0 adalah yang kita kira tadi, and then V0 adalah, since V constant kan, V constant, which is samalah dekat sini, kita akan guna 12 volt. So akan dapat 3.396 eksponen negatif 10 coulomb. Okay, sekarang kita sudah dapat Q0. Now we want to find the value for Q, which is final charge. So still kita tidak boleh juga gunakan Q is equal to CV. So we can find the value for C first. So since kita sudah carikan value for C0, so C will be equal to epsilon R times with C0. Sebab capacitance akan increase apabila dielectric diletakkan. So dielectric tu dia bagi tadi 3.7, C0 sudah dapat 2.83 eksponen negatif 11. So dapatlah capacitance 1.05 eksponen negatif 11 farad. So now we can find the Q here. Q is equal to CV, 1.05 eksponen negatif 11 times with 12, and then you get the charge. So this one will be the final charge, 1.26 eksponen negatif 9 coulomb. And then we can find the delta Q, the change. So tolaklah Q0 minus Q, 3.396 eksponen negatif 10 minus 1.26 eksponen negatif 9. Okay, sorry, silap So yang besar tolak yang kecil, which is Q minus Q0. Q adalah 1.26 eksponen negatif 9 minus 3.396 eksponen negatif 10. So dapat 9.2 eksponen negatif 10 coulomb. So that will be the question, okay, the answer for question D.